Can you hear more? Good morning and welcome to our class for today. Let's not waste time. Let's just go. Let's just try and finish what we were doing the last time. So we're looking at list and for loops. Okay. So we were at okay. I showed you all these ones last in the last class. Sorry, like I said, our class will be more of practicals. I'm not going to be doing. In the practicals, we'll be talking. So we did while loops, right? We look at while loops in the last class, um, and we actually did this one. I think this is where we stopped. We did this. We did this. So we actually did this one as well, right? You see, enter your name, password. So that one we did. So here, just like a continuation, right? This is starting by setting a variable x to zero. X is equal to zero, while x is less than 3. Print x is currently, then you now print x, then print adding 1 to x. So this here we're incrementing, right? So we look at this. So what this logic, I mean, what this statement is saying, while x is less than 3, you should keep on doing this. Print x is currently, so that's what it's doing. Then we'll now say adding 1 to x. So once this condition is met, it stops, right? Can't folk tales by moonlight. Can't you see my screen? Hello, can you see my screen? Can everyone see my screen? Okay. All right. Thank you. So let's proceed. Say note, be careful with while loops. There is a potential to write a condition that always remains true, meaning you have an infinite running while loop. If this happens, you can stop slash restart the kernel like what I did here. Because I've done all these ones, I did want to run them again, and I'd already written this code for this class. So I don't want to like just run my kernel from where we stopped in the last class. So we have what they call the break keyword. The break keyword allows you to break out of the loop that contains the break keyword. For example, look at this. Let's look at this statement. We say x is equal to 0, right? While x is less than Okay, sorry. Can you hear me now? Can you see me now as well? Folk tales, you say can't see what you are teaching. I don't understand. I say you couldn't see what I was teaching, or what's the problem here? All right, let me proceed. We have x is equal to 0. And so while x is less than 10, print x. So adding 1 to x and all that. I believe we understand this logic. So if x is equal to 0, so there's a difference between this double equal to. You can't see my demonstration. Okay. All right. Not a problem. Not a problem. Welcome, sir. So what I'm saying here, I've already pre-written these codes. Are you with me? I've already pre-written this code. First of all, let me even ask you: do you have folk tales? Do you have what do they call it? Do you have Jupyter Notebook installed? Do you have Jupyter Notebook installed? I've already pre-written this code, right? So unless you want me to rewrite them again, right? Unless you want me to rewrite them again, then I will write them for you. But I feel at this point, because of the timing that we have, I don't want to be writing so much code because it will actually take our time, right? That's why the codes are here. But I'm actually going to explain each line for you. This line here, x equal to 0, is you're assigning x to, you're assigning a value 0 to x. X is a variable here. We talked about that in the first class. So we're assigning 0 to x. So we're now bringing in our loop statement, which says while x, right? You're not on the same page with my slide. I've not shared the slide. Damn it. Let me get something. You can't see my Jupyter notebook. Can't you see what I'm presenting? I'm using Jupyter notebook to present. You're supposed to download Jupyter notebook and it is spelled Jupyter with a Y. It is spelled Jupyter with a Y, like this. Jupyter. Jupyter notebook. Right? This is how it is spelled, Jupyter notebook. So you're supposed to get Jupyter notebook. All right. So what's the problem? Can't you see what I'm presenting? Because if you can't see what I'm presenting is actually as good as 0. Can you see my presentation? Can I proceed? No. So what's the problem? You can't see what I'm presenting. Please, who else can't see what I'm presenting? Oh God. What do we do now? Good morning, Mr. Anas. Can you see my presentation? Can everybody see my presentation? Because from my own end, it shows that my presentation is good. It's actually showing, right? All right, all right. No problem, no problem. Let's stop presenting for now. But can you see me? Can you see me? Can you see me? Am I moving? Can you see me move? You can't see me either. Are you serious? Ah, wow. All right. I'm back online. Hello. Sorry. Can you hear me now? Hello? Please, if you can hear me, say something or type something. I don't know why my this thing will just not be showing.
It's still not showing.
It's my the screen I want to share. Present, share screen, share. Can you see my screen now? Can you see my screen? It's not me I want you to see. If you can see my screen, it's better. You don't have to see me. The screen is more important. So can I proceed? All right, so let's go. So I was talking about the break code, right? I was explaining this line of codes. So the break code was still using the while statement. Mr. Chisom Felix, I'll be Miss Chisom Felix. I don't know. Probably, I don't know whether it's your network, but I've been asking, can everybody see my screen and is it visible enough? Is it visible enough? All right. Since I'm getting no answer, I'll take it as if you guys are seeing my screen. So x is equal to 0. So we're initializing here. Initializing. Initializing x here. Right? So we now said while x is less than 10. Like I told you, always end this with what? A colon. Always end it with a colon, right? If not, when you put a colon, it gives you an automatic indenting. This is an indenting from here to here. If I don't put a colon, right? Let me show you what happens. Can you see? It doesn't indent for me. And part of the syntax is that if you put an indent, it automatic. If you put a colon rather, it automatically indents for you. Okay, okay, okay. Not a problem, sir. Is it visible now? I've zoomed in. All right. So when you do that, x by initializing, we set our condition here. While x is less than 10, print x, right? Then we'll now increase x here, incrementing value of x here. So here we're printing x, then we'll now print adding 1 to x. What this one will do now, this is for this line here to increment x. Understand? Now you now have a logic. I have a logic here. If x is equal to 3, I want to talk about this double equal to. right? And this one equal to. So in Python, right? If you see just one equal sign, it means it's an assignment value. Are you with me? It means it is an assignment value. Assignment means you are assigning a variable, you're assigning an item to a variable. Do you understand? You're assigning an item to a variable. That's what this one equal sign means. Then a double equal sign now, this is actually what we call equal to in Python. Are you with me? One equal sign is an assignment. It's an assignment operator. Double equal sign is the equal to operator. So when you see this x equal to 0, that means I'm assigning 0 to what? X. So initializing x, assigning 0, assigning 0 to x, right? So here, while x is less than 10, print x, print adding 1 to x. So here we're now increasing x. So whatever we're going to increase here will now be assigned as a new value of x, right? Incrementing value of x by 1, right? And assigning it to x. Are we together? So when we do that, we now see, let me just explain something to you quickly. X is equal to 0, right? While x is less than 10, print x. So to print 0 here, that will be the first output, 0. Then it will now print adding 1 to x, right? Then it will now increase this one, x plus 1, which is now 0 plus 1, which now go to 1. The new value of x is 1. We now come back here and what? Compare. So look at this condition here. It says if x is equal to 3, there's a comment here. This will cause to break out of the top loop. Note that if statements don't count as what? Loops. Please note that if statements don't count as loops, they're actually conditional statements and they are used for us to write logics. So here, what this will do now, let's print it and see. Can you see the output? If you look at this, we said while x, or do you know what? Let me comment this out first. Let you see something. Let me comment this out and let me comment this out. Right? Let's run this and see. So can you see what happens? Right? I'm only running this block of code from here to here. I'm only running from here to here for now. Right? Welcome, Samuel. I'm only running from here to here, right? Now, when I run this, it will actually run this whole statement while x is less than what? 10. It will run everything for me. That's why you see it goes up to 9 here, right? But now, if I now bring in the if statement, right, and the break statement, it will not run this whole code because of this condition here, because of this logic here. It now says if x is equal to 3, break, right? So instead of you running the whole 10 loop, instead of you running the loop 10 times, once it sees the statement here, it will now what? Break. So let's run it again, let you see. So can you see the output here? So first of all, when it ran the first time, it gave us 0. Added 1 to x, it gave us 1. Added 1 to x, it gave us 2. That means it has run how many times? 1, 2, 3 times. Not that if x is equal to 3, right? If x now runs 3 times, right? We can now say you should what? Break. Is that okay? Hope no question. Because I want to proceed now. All right, so let's proceed. So now let us go to for loop. For loop. For loop. Now there's another type of loop called for, and they say a for loop acts as an iterator or iterator in Python. It goes through items that are in sequence or any other iterable item. Objects that we have learned about that we can iterate include strings, lists, tuples, and even built-in iterables for dictionaries such as the key or values, right? Some data types, yes, I will. I'll do that. That will be the last item on the this thing. So, like we said, a for loop is an iterator. You know when something is being iterated, right? It's more like it's repeating. Understand? It's repeating something until a condition has asked it to stop. Understand? So it keeps on iterating. So the objects that we can use or we can iterate over include strings. So the data types that we can iterate over strings, we can iterate over tuples, we can iterate over lists, and we can even iterate for dictionary. These are data types that we can what? Iterate under. So here, for the general format of a for loop, it goes like this: for item in objects, statements to do stuff, right? For item in an object, statement to do stuff. The value name, the variable name used for the item is completely up to the coder. So there's no like, it's not that there is a built-in name that you might use. The variable name, that this item here, this is the variable name, right? Is completely up to the coder, that is you and I. So use the best judgment for choosing a name that makes sense and you will be able to understand when revisiting your what code. So this is a very very important point because when as a coder, when you go back to revisit your code, you don't come and tell yourself that I've forgotten what I used to name this variable. I mean that would be very funny. So let's look at for loop with a list. So let's look at a list. How do we iterate over a list? Right? So we have a list here, which is called my list. I showed you how to declare list the last time. So for those of you that were not in class the last time, I'm coming down to all right. For those of you that were not in class the last time, this is how we declare a list. My list, right? My list. This is the variable name. Then we're now assigning the value of this list into this variable. And how do we do it? A list is ordered by what? Square brackets. You open the square bracket, you now put the numbers in the list, right? Or whatever item you want to put in the list. A list can carry numbers, it can carry strings, it can also carry another list. We saw it in the last class. So my list is equal to 1, 2, 3, 4. Now, can you see the variable name? And now say for number, NUM, for num in my list, print what? None, right? So what it's going to do for me is going to print out all these numbers, 1, 2, 3, and what? And 4. Can you see that? It has printed 1, 2, 3, and what? 4. Now, what I want to do here now, right? I want to print the square of each number. Print the square of each number. So when I run this, can you see? It gives me the square of 1. This statement here says print item. So if you want to write the square of a number in Python, right? What we do is this. If I say A is equal to 5, sorry, A is equal to 5, and I now say A, I'll now use the 2 asterisk sign, A raised to the power of 2, right? Let's run this and see. Can you see what happens here? It give me what? 25. This is the output here. So please don't forget this. So this is what? Exponential exponent or raised to the power. So let's call it power, anyone that item. From here, it was item, right? From here, you see it was number. It was num, N-U-M. And anyhow, whether I still write, if I like, I can put my name there, right? If I like, I can put my name. I can say for essay in my list, right? Don't forget to always put your words, semicolon, right? I'll now say print essay. It will still print the same thing for me. So that's why they said, whatever you choose to, let's come back to this line. So the variable name you choose for the item is completely up to you, right? So just choose the right variable name. So same thing here. I showed you how to write exponent. Same thing here. So here, now say for num in my list, print number, then end with what? Space. Let us see what this will do. Can you see the difference here? The difference here is this. You know, if you look at this, we're actually printing vertically, right? What if now you want to print horizontally? So when you now do this, you now say for num in my list, print number, comma, end equal to what? That this bracket here, if you look at it, there is a space. So the end, so after the end of every number, leave a space, print the next one, leave a space, print the next one, leave a space, print the next one. That's what basically this end here and this empty space here is telling us. You understand? So that's how you can print in a straight line. So they say for none in my list, print I am in a for loop. So this will actually work, but to just print what I am in a for loop 4 times. Do you understand? So you see, it's not only the numbers in the list that are to print. You can actually print another thing, but by what? The number of times in that list. So for number in my list, how many numbers do we have? One, two, three, four. Print I am in a for loop. So to print it what? 4 times for us. So let's look at for loops with strings. For loops with strings. We just look at lists, right? For loops with string. Like I said, a string is just a combination of what? Alphabets, right? And they are all in what? Quotation. So if you want to declare a string, right, you have to put a string in what? Quotation. We now say for character in this is a string. So the whole of this is a string. Another way I can write this, right? I can say string is equal to string is equal to, so let me just copy the whole of this. Let me cut it and I'll paste it here, right? And I'll say string is equal to, this is a string. For character in what? I'll say string, right? And now tell me print character. Can you see? This will work. But the problem now is that it is printing it what? Vertically, and we will not want this because it doesn't make sense. It doesn't even look like this. It doesn't even look good like this. This THIS, then space IS, blah blah blah. So what we're going to do now, to do this, we can actually change it. Now say my string is equal to, this is a string. Please don't mind the variable name I'm using here. Let me revert back to this one I used earlier. Let's use string, right? I just is a string. This is a string. But what if we now want to put it in one line? Let's try that our end method and see, right? So let me copy the whole of this. Control C, Control V, right? For word, comma, end is equal to is equal to is equal to this. So let us see how this will work for us. So can you see? So this actually works. So what this means is that for every word, print a space at the end of the word. This one here, dot split. What dot split does is that it now splits the string into each of the words instead of just the alphabet. I believe we are all good and we understand what we're doing here. If there's a question, let's ask, please. Question time. If there's any question before we proceed. The color effect. I don't understand, Samuel Joseph. Which color effect? The one on the. Are you talking about this? Are you talking about this four in print, the green and the blue? Is that what you're talking about? No, I will. Sorry, let me apologize to you guys. I've not uploaded them on the platform yet, but I'll do that. I've been saying I'll do that. Just that I've been overwhelmed, but as soon as I'm done with this class, I will all the material that I have, I'll put them in this thing and upload them to you. So please, sorry about the me not uploading it in time. But as for the materials, you get them. You get them. All right. Since there's no question, let's proceed. The next one now, let's look at a sentence. This is a popular sentence we use. Where does it come from? Contrary to popular belief, just a random statement. This lorem ipsum is a very popular. This if you go to Google and type lorem ipsum, they use it for a lot of programming examples. Okay, the different colors green, blue, and red. Green is used for keywords in Python. They are keywords. If you look at this, for is a keyword, it's in green. In is a keyword. Print is a keyword. What that means is that you see this word, you can never use them to declare variables. Are you with me? So if you're typing in Python, if you're typing in Python, right? On, okay, on is not a keyword, and it turns green to you. Just know that that is a keyword. Are you with me? And what should that keyword? There are a lot of keywords, but if you're using this specific development environment, there are some keywords that when you type them, there are keywords in Python that when you type them, can you see type two is a keyword. So keywords and methods are green because type and print are existing. Then for the blue, sorry, blue is for methods. String dot split. What this plus split now is it's actually going to split the whole string for me into the words is supposed to print it for me. So that's basically why they are green, they are red, and they are yes, four is green, like I said. Four is green, four is a keyword. You understand? Four is a keyword, four is a keyword, in is a keyword. Then blue dot split is a method, right? Then we talk about the red. For example, now the red now, let me show you something. When I declare a string, right? Can you see? It's in red. Let me remove this. Let me remove the what they call it. Can you see? It's back to this. Is a keyword. Can you see is here is green? So if I'm to run this, it will not work in any way because it doesn't identify this thing as anything. And here there is a keyword. So it will just think probably the function of this is now should probably work here. So to give me an error. So for me to make this thing work as a string, I will now introduce what? I will now introduce, sorry, I will now introduce this. I'll now introduce this. You understand? So once you declare this as this, it automatically sees it as a string. So when you see red in quotation mark, it is as a string. Like same thing here. Same thing here. So it sees it as a string. So we're using triple quotation mark here because we are writing a whole lot of things here. If you look at it, it's very plenty. So we're using triple quotation mark, right? Because the whole is very plenty. And if you also come here, you can see that there's also a quote here. So what triple quotation mark will do for us will tell us that okay, um, this is going to be like a very lengthy string. That's why we're using triple quotation mark. It will be a very lengthy string, and there might be quotations or quotes somewhere. So you see, we end with what our triple quotation mark as well. I hope I've answered your question, sir, Mr. Samuel. Let's continue with our for loops in string. So let me run this. So I've run this sentence. So like we did initially in our while loop, we always have an initializer. But in for, we have what they call a counter. For this one, we want to find use a counter. They say counter is equal to 0, right? Now say for item in sentence, for item in this sentence here, right? If item, remember what I told you about this double equal to? This is what now? If item is equal to I, counter plus 1, then print counter. Who can tell me what this thing will do? The pink. Okay, the pink is when I'm using operations like equal to and plus. That's this color, right? When I'm using operations equal to and plus, that's when you see that color will pop up. So you see, it helps us to understand and differentiate certain things. So that's what the pink does. So back here, counter is equal to 0 for item in sentence, right? So if item is equal to I, counter plus 1. So we want to know how many I's are in this thing. That's what this thing is doing here. This print statement will not print I. For those of you thinking to print I, it will print how many I's are there. So to give us a number. So it tells us that there are 60 I's in this word, in this sentence. I hope we get that. So there are 60 I's in this sentence. So you can do the same for the E's. You can do for the same for the for the whatever you want to do. Right? Let's try something here. Control C, Control V. So if we say for item equal to, let's try a word, ipsum, right? For item equal to ipsum, print what? Counter. So it's telling me ipsum is 0. That's not, it's not possible. Okay, okay. Probably it's case sensitive. Let's try something because ipsum. Okay, it's still telling me that it's 0. Probably it can't count. It can't count word. Can't count that. So let's see maybe E. Let's try E. So it tells me there are 89 E's here, right? Tells me there are 89 E's here. So that's how you can get the number of get the number of alphabets in a certain string. So let's look at for loop with tuple. We didn't talk about tuple in the last class, but I actually okay, we talked about it, but we didn't see it. I said a tuple is like a list, right? But a tuple is being declared with what? Parentheses, right? This is a tuple, and this is a list. This is a list. So I can say B is equal to B is equal to 1, 2, 3, 4, and then 5. So that's a list. So this is the difference between a tuple and what? A list. So that's the difference between the two. So that's just by the way. And the difference between a tuple and a list is that a tuple uses parentheses, while a list uses square brackets. You understand? A tuple uses parentheses, while a list uses square brackets. Another difference is that a tuple is mutable. This is how to spell mutable. Mutable. A tuple is mutable, right? And what that means is that it is liable to change. It can be changed, right? It can be changed. While a list is immutable, that means it cannot be what? Changed. The items in a list cannot be what? Changed, right? So just like I said, a distinct is what? Mutable. A list is mutable, while a tuple is not mutable. We have other functions that are mutable. We have other data types that are mutable in Python. That are mutable in Python. Right? So what that means is that once I declare a tuple, I cannot want to come and I cannot say I want to start changing these things. I believe you saw a list with all those dot append, dot pop, dot this, dot that. You cannot really do that you cannot really do that with a tuple, but you can do that with a what? List. So let's run this and see. Let's print A. Then let's look at what type is this. We tell us that what it is a what? A tuple. So I have another variable that said tup is equal to 1, 2, 3, 4. For number in tup, print number, comma, n. So what this will do to print it in a straight line for us, right? So let's look at this now. We have what they call list of tuples. Like I told you, a list can take anything. A list can take a list can take a string, a list can take an integer, it can take a complex number, it can also take a tuple. So this is a list of tuples. What that means is that we have tuples inside the list. Right? So let's print it and see. So that's how it is printed, right? So let's look at the type. Who can tell me what type will it give us if I run it? What type will this give us? If I say type list of tops, what type will it give us? Any idea? Okay, let's run it and see. So you see, tell that what it is a list. So please do, if you said tuple in your mind, you are wrong. It tells that it is what? It is a list because the tuples are in what? A list. Let's see how we can look through that list of tuples and see for x in list of tuples, print x, right? For x in list of tuples, print x. So it's going to print everything for me. It's going to print it like this for me, right? You know, like I said, if you want it to be in a straight line, please don't forget to do this. Don't forget to do this. Right? Once you do this, you can always have it in this format. But if you don't want that, you can take it out and then you run this. So to give you in a vertical format. But if you want it in a horizontal format, always put your end like that. So we can also get the index. You can print the index. So see for x in list of 2, print x index 0. So what that happens is that it will print all the ones in index 0. Look at all these are in index 0. You understand? So it's just printing all the first values in index 0. If we say print index 1, we're going to have this as what? As well. I have that as well. For number 1, number 2 in list of print number 1, print number 2. Then we have a new line. What this slash n means, right? Is a new line. You understand? Slash n means print it in a new line. So if you look at this, you say print number 1, print number 2, print number 1, print number 2. So in each of the tuples, to print the first one, the second one, then new line. That's what it will just be doing that for us till we print everything. If you use Python in command line interface, it worked. For example, I did 2 plus 2, and I also did A plus B, and I got what I needed as an answer, but I didn't get the answer. So you're using command line prompt, you're using the command line interface, and you did 2 plus 2. Then A plus B, did you declare what A and what B is? If you didn't declare a B, I don't get why. He said it didn't work. I didn't get any answer in Jupyter Notebook. What are you pressing? How are you using to compile the code? Are you just hitting enter to compile the code in Jupyter Notebook? That's another thing you should ask. To run codes in Jupyter Notebook, right? We don't use just enter. You can either use control and enter. You press it together, control and enter. Then you now get the answer. Or you use shift and enter. What shift and enter will do is that it will give you the answer and open a new cell for you. I don't know if that answers your question. So you don't just press enter or Jupyter Notebook for it to give you an answer. You have to use shift and enter. So let's continue with for loop with dictionary. So a dictionary is another data type we have in Python. And a dictionary as well is mutable. You understand? Let me tell you why we cannot use the for loop in a tuple. Okay, let's try something. Let's try something before we move to for loop. Let's say is equal a is equal to 1, 2, 3, 4. Then I'll now say for item in A, for item in A, print item. Okay, so it actually works. So we can loop through a please probably try again. Because if you say 2 plus 2, let's try what you said here. This is Jupyter Notebook, right? If I say 2 plus 2, 2 plus 2, can you see? It gives me 4, right? Then even if I want to 2 plus 2 gives me 4. And even if I want to declare, let's say A is equal to 2, right? Then B is equal to another 2, right? And I'll come and say A A plus B to still give me the same answer. Do you understand? So I don't know whether that was what you're talking about, but I just did mine and it's actually working. But you have to declare what A is and what B is. If I do like, let's say if I do something like this now, if I say C plus D and I run it, can you see? It says C is not defined. Likewise, D is not defined. So you have to declare it before you can run it. Okay. Was that the A and the B was giving you the red and green colors? Well, just like I said, if you see a red and a green color, it's not going to work. Red and green color. Red and green color. Wow. I don't think I really get what's happening to yours. Red and green color. Because like I explained what the red and green colors do. Like now, see this one now, this is a string. And because I'm putting it in a dictionary, when I pair it, the one here will become green. That is why this one is like this. So this one is understandable. Like I said, there are certain statements like this, right? This is a keyword in Python. You understand? It's a keyword in Python. So you cannot, if you type it, it will definitely show you green. To definitely show you green. You understand? To show you green. So that's why those ones cannot work. Another one, some keywords we have and. Can you see? We have assert. So all these are keywords. If you type them, you cannot use them to say you want to clear anything. I don't know if I'm making sense. So there are some keywords. So if you want to know the keyword, let me just drop it here for you guys. Okay, so I cannot actually sorry, give me a minute. I'm trying to share something. All right. Well, I can't really share this thing. Probably I'll drop the link. Okay, let me put it here. Maybe you will see it when I share the notes. So to get the keywords in Python, so I'll just put. Let me use Markdown. So that's actually the. This is for where you get keywords in Python. So keywords in Python. You can see them there. You can see them in this link, so that you know when to the ones to use and the ones not to use. There are a lot, there are a whole lot. So you know when to use them and when not to use them. So let's look at dictionaries. Follow up with dictionaries. This is how we declare a dictionary. I said the variable name is totally dependent on you, right? If you want to use a variable name, please let me also share a list of variable names that are good in Python. Let me also share that so that you know the type of variable names that you are supposed to use. So I'll also share this for you. Let me still drop it here as well. So this is what variable names in Python. So you can have that as well. So these are for variable names and that's for um, keywords. So let's come back to what we're doing. So I said this is a dictionary. I don't think I've really declared a dictionary, but we're just going to declare it now. My dictionary, like I said, this is the variable name, right? So anything you can choose to name it A, you can choose to put your name there, as long as the condition meets what is in this link I sent to you. You will see the type of appropriate variable names you're supposed to use and the ones you're not supposed to use. So my dictionary is equal to dictionaries are declared with curly brackets like this, right? This is how you declare a dictionary with curly brackets. That's what I did here. And a dictionary is what they call a key value pair. Can you see here? We have A and we have a column, then one. So this is like the key. The one on the left is the key. The one on the right is the value. So A is the key, one is the value. B is the key, two is the value. C is the key, and then three is the value. So let's run this, right? Um, Let me print this. So I'll say print my underscore dictionary. So let's print this. Can you see how it looks? This is how we'll print it. So remember, dictionaries don't retain an order. So any loop through them, so only loop through them with this in mind. So they say dictionaries don't retain any order. They don't retain any order. Let's see what we're doing here. See for item in my dictionary, print item. Figure. So it's just going to print this key value pair. Now say for k in my dictionary dot value. So this one now is actually helping us get the value. Why they say it doesn't retain any order is because, like I told you, it's a key value pair. So when we said for item in my dictionary, it's going to print the key for us. So if you want to print the value now, we have to now use the dot values method, right? Dot values method. So print k. So can you see that is when it is now printing what the values. So this IDE understands that when declaring a variable, it has a key and has a what value. So if you want to say for k in my dictionary dot keys, print k, print my dictionary k. Let's see what this does. So can you see this? So for k in my dictionary, print k. That's what it did here. It printed k, right? Then print my dictionary k. So what is one now? It is now printing this second line here is now what is now printing the values for us. I will now say in a new line, print in a new line. Let me comment this out and see. So can you see without it being that, that's what happens. That's what happens. So that's basically how that works. So we now have what they call the continue keyword. The continue keyword can be a bit tricky to see its usefulness, but it allows you to continue with the top level loop, basically the opposite of break, right? It will take time before you realize a good situation to use it in, but here is a simple example. It says scores is equal to 30, 40, 50. So this is a list called scores. For number in scores, if number is equal to 50, continue. Print your score is what? Number. So let's see what this will do. So now said, so if you look at this, right, what the continue does is, it's more like, that's why they say it's kind of tricky. It's kind of tricky because from this logic that we have here, scores is equal to 30, 40, 50, and what, 60. Then I say for number in scores, if number is equal to 50, continue. Print your score is this. So what that means is that once you hit 50, don't print 50. Eh? Jump 50 and what? Continue. Let me explain it like that for you. Right? Jump 50 and then continue. So what you can see if you're printing here, we're printing 30, 40. You see there's no 50 here. So it keep 50 and it what? Continue. Let's look at another example here. Now said for letter in code, if letter is equal to E, continue. Print current letter is, then you put the letter. So let's see what this is. So if you look at this, right, it will print C O D, but it won't print E. Let's put something that is in the middle. Okay, let's try C. Can you see what happens here? So that's basically how it works. That's basically how it works. So you can also do this. Current letter is O, current letter is D, current letter is what? E, if you choose to use this method. So, but I think this is not bad because we have to differentiate it as well. So that brings us to the end of for loop and the other one. So our next topic will be conditional statements. Conditional statements. So I'll stop sharing this so that we can look at the other one. So let me stop sharing this. So let me share the other one. Sorry, it's coming up. All right, so let me share this. Can you see my screen? Okay, I'm trying to share my screen. but I don't know what is happening. So please give me a minute. Let me leave this thing and come back. I don't know. I can't. My screen is not. My screen is not popping up. Please let me leave the classroom a while and come back to connect. My screen is not showing. Just give me a minute. Okay, let me try sharing my screen again. You say I should restart my computer. No, if I computer, it will take time now. Take a whole lot of time. Okay. Can you see my screen now? I think it's back. I think we're back. Can you see my screen? 01308 Hello. Okay, yeah, nice. Thank you, Samuel Joseph, for that confirmation. So we are now in conditional statements. Now they said, like I said, conditional statements are not looping statements, but majority of times when we're programming, we use them to control flow or of our mode. That's why I said the thing kicked me out again. That's what kicked me out this time. Can you let me back in? Hello? All right, thank you. Is this how your this thing is? Your earpiece?
Yes.
You don't have the normal earpiece for
Which one is normal?
that one that is cheap.
Eh?
The one that is cheap.
I don't know what you're talking about.
No earpiece are like, do you have this pin place on your phone
No,
for
no, no,
earpiece?
no.
What phone is this?
This Galaxy.
Okay. Can you hear me? Sorry, my network kicked me out. Can you hear me? Class hasn't ended. We are still here. Network just went bad and took me out. Hello, can you hear me? We still have more time before the class will end. Hello? Anyone there? Okay, nice. So we're back. So let's continue. So I was talking about the if. Sorry, it was a network. So here I said when you have a good logic here, one is less than two, it's going to print. But whenever we have one that is not good, which is one is greater than two, which is not true, can you see what happened? When I ran it, nothing happened. So notice what happens. The ignited block of code only runs when if condition is what? True. Let's look at if else statements. Let's now add in an alternate action in the case the if is not true using the else statement. Notice the format and how the code block line up. This is crucial in Python. Code indentation lets Python know the block statement correspond together. So just in the case whereby we want to put different logic, we now say if 1 is equal to 1, print 1 is equal to 1. Else, print first if was not true. So this one basically it will print the first statement because it has compared these two and it knows that they are what? Equal. So it will print the first statement and it will print the second one. Let's look at another statement. It says if 1 is equal to 2, print 1 is equal to 2. Else, print first if was not true. So to definitely print the second statement because once it sees that this first print here doesn't correspond with what is in the logic, it will go and look for whether there is an else. If there's an else, it will now what? Print the else. That's what that means. So that's how we have if else, right? We also have if else and what? If, which we are going to see. Let's look at this one. It says save password is equal to 1234556. New password, input your what? Password. If int, this int here means integer. If integer new password is equal to save password, print password correct. Else, print you are a criminal. So let's see what we're going to do here. Say enter the password. When you let's try something 1, 2, 3, 4, 5, 6. So you see, basically when you type a password, it automatically asks you whether you should save it. It will save in the database of the system you're using, right? So, but not sometimes when you forget the password and you come and type another one, it will probably log you out. It will tell you password not correct. If you do it for 3 times, it might block you or tell you to change password if you want to. So this saved password here is probably the password that was saved by that system. So it's now telling you input to enter your what? Password, right? Forget this. Is this one just a variable here, right? So probably I can see this one now, password. Forget the new here. Input, enter your password. If integer new password is equal to save password, this is the save password. This int here is telling us that since we are using integers here, let us put the int. If you don't put this int, it won't work. Then print password correct, then else you're a criminal. Let's run this again using a different password. Let me say I'm using 1, 2, 4, 5, 6, 7. Can you see? It tells me that what? I am a criminal. You understand? It tells me I
That's
am
what you are.
tells me I am a criminal. So let's look at another one. They say if 4 is less than 3, print the answer is correct, else print wrong answer. So to print the wrong answer. So let's look at if, if, and else. Now let's imagine we have multiple conditions to check before the final else statement. This is where we can use the if keyword to check
Hello?
for
Hello?
as many individual conditions as necessary. So let's start. Say if 2 is equal to 0,
I can
print
hear you.
first condition is true. If 2 is equal to 1, print second condition is true.
Come to this one.
If 2 is equal to 2, print 10th condition is true. Then else, print none of the conditions were true, right? So what this will do now, this is our logic we're looking for. If 2 is equal to 0, this is the first one, right? Print first condition is true. this is not true, so you can never print. This line of code here is not true, so it will not print. So if you see that this is not true, to jump to the next line, which is the L, if the next logic, 2 is equal to 1. Is it true? It's not true. So to not do this one, L if
Hello?
2 is equal to 2, printed condition is true. It will print this one. So let's run this one and see. So it says third condition is what? True. But if I now come and change it to 2 is equal to 3, it will print what? The else statement for me. That is how we control logic in this situation, right? You can use so just in most times, this is what I wanted to show you guys. So let me just run this. Let me run this. So you see, this one first condition is what? True. It said every condition here is true. But because the first condition is true, it will just print the first condition and neglect the other ones. Okay, so what I wanted to show you now is this L if and if statement can work very well when you're grading your students. For those that are teachers or those that have some form of academic background that you use to grade, not really, probably you have some form of this that you use to grade. We can use the L if to actually get grades of students. Maybe to actually give them scores or grades rather. So let's look at this. We're going to have an input box, right? And we're using the integer. We're using the integer method here because our scores are integer. So score is equal to int input, enter your words, enter your score, right? If score is greater than or equal to 70, print your grade is what? A. Else if score greater than or equal to 60, print your grade is what? B. Else if score greater than or equal to 50, print your grade is what? C. Else if score greater than or equal to 40, print your grade is what? D. Else if score greater than or equal to 30, print your grade is what? E. Else print your grade is what? F. So let's run this and see. So let's try 80 and see first. Can you see? Your grade is what? A. If I come and say 29, your grade is what? F. So this is a very simple way folk tales. What's the problem? We don't really understand how the whole thing is working today. I'm listening to you. What's the problem?
Are you using? Is it typing?
No, I'm typing and
No, is the person you're talking to, is it typing?
no, he's typing, yes.
Okay.
So please, why don't you understand? Type, let's know. You can lay down your complaint. Let's see if we can solve them before we proceed. Folk Tales by Moonlight. Should I proceed when you're ready? I'll come back to you, but I don't want to proceed so that we'll now be drawn back. So please, if you have a question, you can ask. At the same time, I'm trying to beat time because we don't really have time. Okay. Yeah, when I reconnected, I asked if anyone hear me around you asked a question around 2:27 that says what's going on as the class ended. Before going, I said please let me disconnect because I couldn't share my screen. I don't know if you heard me. I took permission for that. Then I now came back 12:28 and asked if you could hear me. Then one Benga Akin one day said yes. Someone Joseph said yes. Someone Joseph said we can hear you, sir. So you get, so you now said I don't really understand how the whole thing is working out today. So probably when you came back on, I had already gone because I noticed this your message came in 12:34. So I'd already gone back, I'd already gone. But just like we all know, the videos are there for us. Thank you very much. Anna Salisu Adam. For Jupyter Notebook, you go to Anaconda, you go to this site. For Jupyter Notebook, please go to this site. For Jupyter Notebook, please, this is the site you will go to. So yeah, from here, when you download this, you have different packages. Even the Jupyter, I mean, you have different packages once you open it. But please, what we are looking at is just Anaconda. I mean, is Jupyter. It comes with different packages. Like the way I did my own, I just kind of brought out the Jupyter Notebook. Once you install it, you see the different files. So I took out Jupyter Notebook and kept it in my stats menu, whereby I can always access it. So if you go here, you can, yeah, I think you'll be able to get Anaconda. So Folktales by Moonlight. So please, you can watch the video later, right? I don't want to go back because of time. Thank you for your understanding. So let's proceed. I believe we understand this last part, right? So you are creating a logic to grade students by their scores, right? If your score is greater than or equal to 70, probably you're marking over 100. So 100 to 70, that person has A, right? 69 to 60, that person has B. 59 to 50, that person has what? C. 49 to 40, that person has a D. 39 to 30, that person has an E. And anything else below that, that person is what? Has failed the exam. So that person will now have an F. What was that, sir? Which practical was that? That's the one that we did last week, or the one that we are doing today? Because right now I'm doing mostly practical. So once you do that, like I said, once we run this, we have a text box. This specific code here tells that it's a text box, right? Anything, if you say input in the and then a bracket, you're telling it to give you a text box. But I'm putting an int in front of the whole statement because I want it to be an integer. So when I put here, when I type 89 and I hit enter, it tells me that the person has what? Scored A. So the more times you run this code, right, and you type various numbers, 34, it will give you the respective grade. So all these ones I will kind of skip all these ones
Several.
because this one's what they were really
Several.
doing.
Several.
We're just
This
trying
is the
to
definition of several, more than two, but not many.
we're just trying to build things using different patterns. But I'll skip it because of time. Okay, the attendance link. Have they shared the link this time around? Let me tell them to share the link so that you can. So I don't know if there are any questions so far. We still have like 20. Oh no, we're down up to 20. We have like 17 minutes. But I can actually do dictionaries and frequency tables in 22 minutes if this will permit me to share my screen, because I notice anytime I anytime I switch. Okay. All right. Oh, nice. This is not bad. So let's look at dictionaries, tuples, and sets. We're done with if statements, right? Let's look at dictionaries, tuples, and sets. These are just like background for us. So, like I told you, dictionaries so far, we've seen only how to store data in sequences like string or list. But what if we want to store information another way? Python supports dictionaries, which is a key item data structure. It's just of deciding between sequences like a list and mappings like a dictionary often depends on the specific situation. As you become stronger in programming, choosing the right story format will become more intuitive. Let's cover the basic method. So creating a dictionary. This is how we create a dictionary. I think I've even what am I doing here? Restart and clear outputs. Okay. Like I've told you, a dictionary is a key value pair, right? A key value pair. So you must always have a key and a value. So this is our key. Item one, item two, item three are our keys. One, two, and Abuja are our okay. All right. Are you coming tomorrow? We'll look at that tomorrow before we proceed. Before we the installation of Python, right? We'll look at that tomorrow before we start we'll continue with this class. So please just let's just finish this one today. By tomorrow, we will install Python and install Anaconda again, right? But I will that like I said, I've not uploaded any of my materials yet. I've not uploaded any of my materials yet. I'm still forming them, right? But the ones I've done so far, from the beginning of Python, the introduction, I'm going to upload them up to this module that we have here. So please just give me maybe by tomorrow, I should be able to upload everything. So new dict is the name of my dictionary. So let's run this. So I can print this new underscore DICT. So you see, that's how it is. So you can actually change that's why I said a dictionary is mutable. You can change a specific key. You can see here is Abuja, right? I can choose to change it to what? Kano. Then when I now print it, I will now have what? Kano instead of Abuja that is here. You say make a dictionary with curly brackets to signify the key and a value. So this is how you will declare a dictionary, right? Then we can call the values by their key. If I say D is equal to key 1, it will tell me what? Value 1. D key 2 will tell me what? Value 2. Like I told you, you can add new items to the pairs. So D new key is equal to new item. So if I print the D, it will give me a new and a fourth what? Key. Sorry, where are you? So we only two keys here, right? Key 1 and key 2. So when I add this new item, it gives me a new key, making me have 3 different items in my dictionary. So note, dictionaries are unordered. This may not be clear at first with smaller dictionary, but as dictionaries get larger, they won't retain any other, which means they cannot be sorted. So that's one of the downsides of dictionary. You cannot sort them. If you need the ability to sort, stick with a sequence like a list. Are you with me? So you cannot sort a dictionary, right? You cannot sort a dictionary, but it is mutable. So we have D, that's the name of my dictionary, where A is equal to 1 and Z is equal to 2. So when I print D, I have that. I can add a new key with a value 0. So when I print that, I believe I've shown you this already. So we have this now. A1, Z2, then new 0. You can have DZA. I can print this. So can you see? I have another one added here. Hello. So going further, you can see that dictionaries are very flexible in the data types they can hold. They can hold numbers, strings, lists, and even other dictionaries, just like what you saw with lists too. Lists can hold any data type. Lists are also flexible. So let's look at this dictionary. D is equal to K1, that's the key, is 10. K2, 10 here is an integer, it's a number. K2, stringy, this is a string. K3 is a what? List. K4 is now a dictionary that has a list inside it. Are you with me? It's now a dictionary that has a list inside it, a dictionary inside that list, right? And that is how it is. So that's why I tell you it is flexible. So now say DK4 can call out a specific value if you want. DK4 inside key. This inside key is a dictionary too. K4, right? This is the value that we're calling. We're now calling the inside key, right? Index 3, then key inside. Let's run this one and see. Okay, so let's see how we can explain this. So we're calling this value, this key, K4, right? We're looking for it. We're now calling this other key here that is inside the dictionary, right? Then we are now calling the third index. So let's do something here. 1, 2, 0, 1, 2, 3. Okay. Then key inside. Then then we're now taking 1 to the end. All right. What we're doing here is this, right? We want to look for the value 20 and 30 that are in the last value, in the last key. So we're going to call this key K4. We're going to call K4 because that is like the outer key. Then we'll now call this inside key, right? That holds all this value together. It holds all these values. Sorry, pardon my this is all messing up. The inside key holds all this value together from this 20 down to this point here. It holds it. So, like I explained here, we have a dictionary. The outer dictionary, which is this, right? Then inside this dictionary, we have a dictionary that starts here that holds a list, right? And this list also holds another dictionary inside it that holds another list inside it, right? But we want to get this value here, these two. So we'll now say what? The K4, right? Which is what we're now calling this key here, right? We'll call this key, which is this. We'll now call this key because it is what holds everything here, right? The inside key, we have called the inside key. Now we're now back inside the list. How do we call out items in the list? We call them by their what? Index, right? So like I told you, the index starts with 0, 0, 1, 2, 3. That's why we're having 3 here, right? You're now calling this specific item here. Then you now call what? The key inside, which is the key for this list that is here, right? Then we now want to get from 1 to the end. This is 0, this is 1. So if I say 1 and I don't put anything here, I'm taking it from 1 to the end. That's why I have 20 and what? 30. I hope I've not confused you. Because it's quite a process. So the time check is 12:53. So I'll pause here for questions if there are any questions or if there is any question.
Look at the wrong.
You know, they go.
They have a session this afternoon. I don't want to attend.
Please, is there any question? Any question? 12:54. We have 6 more minutes.
See how we when we say now you be the alternate.
Okay. If no question, I will tell you guys to have a nice day, right? And then I'll see you tomorrow by I think 11 or no by 1. Is it 1 for the practical? So have a nice day, please.
Some of my friends now see me doing